We need to verify that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. Okay, let us begin. First, we will construct a quadrilateral ABCD. Now, we're going to consider a point O, which is going to be the origin of some coordinate system. Now, with respect to this particular origin, we can define the position vector of each of the four vertices A, B, C, and D. Now, let us suppose that in quadrilateral ABCD, OA vector defined by A vector, OB vector will be defined by the vector B, OC vector defined by the vector C, and then we have OD vector, which will be defined by the vector D. So let's write down these vectors as well. So B corresponds to B vector, C corresponds to C vector, and D corresponds to D vector. Next, we are going to consider the side AB, and on the side AB, let us consider a point E such that E is going to be the midpoint of AB. In other words, we can say that E divides AB into ratio 1:1 internally. Now, since E is the midpoint of AB, we can also define the position vector of point E. OE vector will be given by A vector plus B vector whole divided by 2. Okay, next we're going to consider the side BC. So here we're going to consider a point, let's call it F. F is going to be the midpoint of BC. Then for the side CD, we're going to consider a point G such that G is the midpoint of CD. And on the side AD, we're going to consider a point H such that H is the midpoint of AD. So using the section formula, we can also define the position vector of each of the remaining midpoints of the other sides of the quadrilateral. So here we have OF vector. The OF vector will be defined as B vector added to C vector whole divided by 2. OG vector is going to be C vector plus D vector whole divided by 2. And then we have OH vector. So OH vector is going to be A vector plus D vector whole divided by 2. Next, what we'll do, we'll join point E and point G because E and G are the midpoints of the opposite sides of a quadrilateral. Similarly, we'll be joining point H and F. So H and F are the midpoints of the opposite sides of the same quadrilateral ABCD. So here we can see here that EG and HF, let's say they bisect each other at the point Q. So our goal will be to prove that the line EG and the line HF bisect each other at point Q. Now, in order to do that, what we'll do, we'll join point G and point F. Then we'll join point F and E, E and H and G. So here we get a new quadrilateral EFGH. We will show that EFGH is a parallelogram, and once we can prove that EFGH is a parallelogram, then we can immediately say that the diagonals of a parallelogram bisects each other. That means, in other words, we will be able to say that GE is going to bisect HF. Okay, so what we'll do, we'll first try to find out the vector GF. Now, GF vector, so GF vector, so in terms of the position vector, it's defined as OF vector minus OG vector. We have OF vector as well as OG vector. So that will be equals to, the OF vector is B vector plus C vector whole divided by 2. And from it, we're going to subtract OG vector, so that's C vector plus D vector divided by 2. And here we get B vector minus D vector divided by 2. Fine. Then we will find out the vector H and E. HE. So here we have HE vector. So HE vector will be defined in terms of the position vector as OA vector minus OH vector. The OE vector, that's A vector plus B vector divided by 2 minus OH vector. So OH vector is A vector plus D vector divided by 2. So we get B vector minus D vector divided by 2. Since both of the two vectors are the same, so here we can say that this implies the GF vector is going to be equals to HE vector. Now, in other words, what we are saying that the magnitude of GF is going to be exactly the same as that of HE, and also since the two vectors are in the same direction, we can say that GF is going to be parallel to HE. Similarly, if we take the vector EF, then we can show that it is going to be equals to the vector HG. In other words, what we have done here is we have showed that EFGH is a parallelogram. So this implies that EFGH is a parallelogram. And if EFGH is a parallelogram, we know that the diagonals of a parallelogram bisect each other, or in other words, we can say that EG bisects HF, which implies that EG bisects HF. And this actually proves our problem, because in the problem we have to prove that EG bisects HF. That means the line segment formed by joining the midpoints of the opposite sides of a quadrilateral bisects each other, hence proved.